So, very good evening to all. I'm audible. Okay. So, very good evening to all. Thank you for joining. So, today we are going to see protocols, communication protocols. So, very good evening, Twin Singh, Steelata, Bharat Raj Singh. Very good evening to all. Thank you for your comments in live chat. Very good evening. So, very good evening. Thank you for joining. Let's wait. Let's wait for a few minutes. Then we'll start the session. So today we are going to see protocols which is used for chip communication in the inside the chip and also outside of the chip. So there are several kinds of communication. So we'll see in this session. So very good evening, Banu Sharma. So thank you for joining. Thank you for your presence. Today our topic is communication protocols. So good evening, Srinivasa Murthy. Or so let's wait for a few minutes. So basically, if you want to share something, your notes or your data or messages, we need communication. Same that reason, same thing in the chips or outside of chip. So if you take like a SoC or processor, microcontroller, there is a lot of blocks are inside the chip. So each and every block inside the chip have to communicate with each other. So based on this communication only, data transfer will happen. So we can get some result from the chip or controller or IC processor, anything. So communication is very important for data transferring from one block to another block. So for that we are using several communication protocols. So without any protocol, so without restriction, so we can't maintain the synchronization in the communication. So that's why we are having protocols. So the name itself is having protocols. So there is a certain protocol we have to follow to achieve the correct communication with speed and data transferring length, like a lot of reasons why we need the protocols. So good evening, Chandralaka. So thank you for joining. So let's get into session. Today protocols already said no to send and receive the data. We need communication. So if you by like humans also we need communication. Same like machines like components like chips and hardwares, we need communication. So real time order we are using the wires. So by using wire we can make communication between the two hardware components. So same thing, so inside our chip also we need communication. So why? Because of if there is no communication means we can't receive some data, we can't do computation, or we can't get the output from the chip. So for that we have to use communication. So if you take an SoC, so say if you take your SoC, it means if your mobile and some FPGAs are so based on the SoC architecture. So SoC is nothing but it having processor and also it having memory, GPU, all the things. If you take a system like a regular system, Windows system, it having the GPU part, it having GPU IC, CPU IC, processor, and then memory, RAM block, and then they are separately are builded, and then by using the motherboard or PCB we are interconnecting these things like RAM, memory, GPUs, processor, and then internal interface and the external interface we are interconnecting by using the PCB, or and then uh, we are making just communication within the single PCB, or we can say like a board. So this is the main board of the computer, like that. But if you take an SoC, that all components are built it inside the SoC. So single is a SoC chip. So single system on chip, it contains all the components like a memory, GPU, RAM, so peripheral interface, and then some DSP blocks, like kind of things. So this is SoC. So if you take in some real-time PCB board for computer, uh, we having some PCB lines. So then we can send the transfer send the data from memory to processor, or GPU to CPU, or interface like a USB port, like that. But if you take in SoC, we can't if you do means there is a size of the mobile phone which will be very large compared to systems. So both are same only. To reduce the size, so we need some protocols, communication protocol, optimized protocols. So there are some on-chip protocols, and also there are some off-chip protocols we are using. So on-chip protocol is nothing but, so if you make communication internally in the SoC chip, so it is called on-chip protocol. So off-chip protocol is nothing but we can make communication outside of the chip. So from a chip to other peripherals, like other external peripheral connections. So by if you do internal communication means we have to use internal, like on-chip protocols. If you do off-chip, like if you do external communication between the chip and some peripheral devices, sensors, displays, we have to use the off-chip protocols. So we will see in this session what are the on-chip protocols and off-chip protocols. So main thing is a protocols very needed to send the data with the synchronous. So by using the protocols, we can say our communication will be fine. So without protocols, we can't sure I will make good communication or not. So that's why we are using protocols. By using protocols, we can assure that. So I'm setting some constraints or restrictions. So this much data you have to send, and then this much of speed, and then frequency, like kind of things. So I'm just assigning some constraints for protocols for communication. So this is called protocols. So each and every protocols are well tested, and they will uh, uh, well uh, will speed. So then only they will publish some protocols. So if some vendors or companies like ARM company will give the AMBA protocols, they are they are doing testing and running the code, so it will works correctly or not. They are ensuring it must be work, so then only they will publish. Without the testing and validation, they won't publish. So each and every protocols takes time to upgrade, and then give the versions of protocols also, which will take so much time. Why? Because of we have to test in from the code, RTL code, and then verification code, and also we have to ensure that it must be work on hardware very smoothly. So if you, while the testing the code, it is work on your simulation, or it will good in simulation, but if you implement in your hardware, sometimes you may receive some error. So we can't make communication between the hardwares. So we have to ensure that both software side, and then hardware size, so hardware side. So based on this testing and validation only, they are giving some pre customized protocol for our communication. So let's see the types of protocols: on-chip protocols and off-chip protocols. So already said, no, on-chip protocols are useful for to make communication inside the chip. So inside the chip we are having some blocks. So we have to make communication from the from the blocks. So we have to use on-chip protocols. So it facilitates the communication within the boundaries of the chip. So it is like a intra-chip communications. There are some examples of protocols like AXI, AHP, Wishbone. So these are the examples. So AXI is a high-speed protocol. So and then AHP is a lesser than AXI. So these all AXI, AHP, APP are protocols, on-chip protocol. This all comes under the AMBA protocols. Let's see what are the number protocols in the upcoming slides. So and then moving to off-chip protocol. So off-chip protocols, is I already said no. It will works on outside of the chip. So from the chip to our peripherals. So if you're using some, if you taken some sensor, if your controller is Arduino board, and then you have to make communication between the sensor and Arduino board. So that's why we need some protocols, or we we need some communication bus kind of things. So for that we are using UART protocol, I2C, SPA protocol. So UART protocol are used for serial communication. So these are the things. So some sensors or displays will send the serial data. For that certain condition we have to use for UART protocol. And then I2C is a data and clock line. If using clock signals in your peripheral device, you can use the I2C protocol. So it's same like SPA also. So SPA is a high speed protocol from in the off chip protocol. It comes under the off chip. So compared to the off chip protocols, SPA is faster than I2C and UART. So what will be RAM memory design section will be covered. So in the previous classes I written some RAM memory code. So that's why I moved to protocols. In the upcoming session, we're gonna see write the RTL code for UART protocol and ABB protocol. So that's why I'm giving some intro about protocols. So RAM memory is a simple thing only. Last class, if you can check means you can check. I already some taken some one session for RAM, so writing code for RAM memory. So that is enough for basic knowledge, but also it is important protocols. So if you want to make communication from RAM to CPU or RAM to other component, so we need some protocols. So that's why I'm taken today protocols. So it is also important topic. So and then I will move to the next slide. So we'll see the on-chip protocol. So on-chip protocol, I said no. They will do communication between inside the block. So inside the chip. So you can see here AMBA protocol. So it stands for Advanced Microcontroller Bus Architecture. So it is like a bus. So by using the bus we can go and come. So we can say same like bus. So by using these AMBA protocol bus architectures, we can send and receive the data simultaneously. And then it is a full duplex, so we can do both sending and receiving the data simultaneously at the same time. It's like a full duplex communication. If for example AXI is a full duplex communication. So why we need the AMBA protocols? Because of, so there are three kinds of AMBA protocols like APP, AHP, AXI. So AHP is it's for using high speed communications inside the chip. So and then APP is for peripheral communication. So from chip to low speed peripheral, low bandwidth peripherals. For that we can use the APP protocol. And then AXI. So AXI is nothing but high speed protocol. So it will perform under the high speed, high frequency, high bandwidth. We can we can use for high speed communications. For example, if you take over a mobile phone, you are using the camera. So input will taken from camera, and then you are seeing some pictures, live pictures from your display. So from display to chip, and then chip to camera. So there is some communication needed. So for that we have to use AXI protocol. So mostly in our SoC, camera interfacing and display interfacing are based on the AXI protocol only. So inside the chip, so if you can see means our that DSP operation, like camera sending and camera and chip communication, data transferring, they are using the AXI protocol bus. So by using AXI, we can send and receive data at high speed. So that's why it is a high speed protocol. So our cameras in our mobile phones are based on the camera and displays are based on the AXI protocols only. So and then if you take any other example like a MIP camera, so there is mostly MIP is one kind of protocol also. So we can also search you can also search on Google what is MIP means. So most of our mobile phones and smart cameras are based on MIP cameras, MIP camera and MIP display. So there is a optimized high speed communication of camera and display. So they are using also AXI and I2C protocols to make the to make the MIP communications. So okay, thank you. So very good evening so to all. So and then let's move to, so this is the on-chip protocol. Why we need the on-chip protocol? To make the communication at high speed. So and then and also inside our chip, the power consumption also must be low. If you're using the physical wire or some PCB lines, it will consume up to 3.32 or 1 volts, but we have to perform under the 3.3 volt inside our chip, like a 1.2 volt. For that we have to use this customize these protocols only we can achieve that, and we can also reduce the chip size. So this is a for example architecture of the AMBA protocols. So you can see here UART timer, keypad, PIO. So these are some external peripherals. So you can see this is a bridge. So you can see here high bandwidth external memory interface. If you can high bandwidth external memory interface means, if you can if you can take also RAM memory or FIFO memory like the kind of thing. So high performance ARM processor, so it may be ARM 7 or ARM 9 processor. So if you it's based on your wish. So and then high bandwidth on chip RAM, and then direct memory access, bus master. So these all high performance high speed come with high speed blocks. So you can see the high speed memory processor must be work on high speed, then only we can make communication speeder, so compared to previous version. So processor must be work on high speed, and then we can also see high bandwidth on chip RAM. So we have to read and write read and write from the memory at the high speed. So then only we can make our computer or mobile phone at a super fast. So for that we are using the AHP, ASP, and also we can use for AXI protocol. For AHP is for high speed communication. So these are the protocols used for high speed high bandwidth block communications. So memory, so if you do something in your mobile phone means, firstly it will move to your memory, and then it will get some data address and register, and then it will perform in the processor, and then it will so it's a kind of the processor architecture. These all things at executed are performed at the it's very less time, like in nanoseconds, like a 0.2 nanosecond, like that. So I yesterday class I said no. So for creating clock for 50 megahertz, we have to give delay for the 10 nanosecond. So 10 nanosecond is a very less time. So based on from that one clock cycle, we have to make this communication. So we have to make some 1 byte or 8 byte or data transfer. So within some less time, like a nanosecond time, we are transferring data from between the blocks. So we have to use for high speed protocols, AXI, AHP, like that. So and then these are the low like a low speed and low bandwidth, low frequency components like a UART. So UART we can use for some serial communication, timer, keypad, keyboard. So these are some low speed components. So it is external interfaces. So you can see here we are we have to communicate low performance low speed devices to high performance high speed devices. So it will works on base very less bandwidth, very less speed, but it will these all things blanks, these all blocks are like a memory block or a processor block, or works on high speed, so they will send at the speed of high, but it will receive the low. So if you directly communicate means, there is a chance to like a conflict or any unknown state, so we can't make communication directly from low speed to high speed. So that's why we are using the bridge. So bridge will directly which the main purpose of bridge is, it will connect the low performance device to high performance low performance devices or blocks to high performance device blocks. So yesterday also we seen, so from the FIFO memory example, it's act as a some bus like kind of things. So one device is works on high speed, high clock speed, so another device is work based on the low clock speed. So we are making some communication by using the FIFO. It's like a buffer. So yesterday we seen the FIFO memory creation. It's like a buffer FIFO, so it will just store the data. So it but it will store in the memory, so it's a FIFO memory, but it is act as a buffer in between the device 1 to device 2. So yesterday we seen some FIFO classes, so that's a reason why FIFO is a buffer in on that scenario. So same like that, here is a bridge. Bridge is used for using communicate between the low speed and high speed devices. So this is the basics of why we need protocols. So why we need the bridge. So if you take in some real SOC kind of architecture, it will be very complex. So it is a very simple block diagram for why communication are needed in our SOCs. So and then let's move to so this is the, yesterday I said no, one day you can imagine, you can also imagine here is a device 1, device 2. So both are both device are works based on the high speed, high frequency, high bandwidth. They can send, so both devices can send the data at the rate of 1 Gbps or 100 Mbps, like kind of things. So for that we have to use AXI data FIFO memory. So it will just you can see a write address. So it is very complex protocol, FIFO AXI protocol. So it has 5 channel, like a write address channel, write data channel, response channel, read address channel, read data channel, clock and reset. So same, this is for master device 1, so this is for slave device 2. So write address, so write address channel, write data channel, response channel, read address channel, read data channel. So you can see here it having the double elements. It means they will easily communicate from on both sides, like a full duplex kind of things. So we'll see in the upcoming classes what is the AXI protocol. So it is also very important protocols. So if you want to enter into VLSI filler SOC kind of ASIC or FPGA, so AXI protocol they are using that only to make communication at high speed. So and then there is also protocols like a PCIe. So PCI is also one protocol. So PCI is nothing but if you take in your computer, there are CPU is there and the GPU is there, and then RAM block is there. So we can also see the some RAM of your computer, like it's like a PCB. It contains 4 chip. We can plug and unplug in our motherboard, in our computer. So this all PCI is a protocol they are using to make communication, to make data transferring between the CPU and the GPU, RAM block and the CPU, or GPU RAM block, like kind of things. So Ethernet also one protocol, USB also one protocol. So if you seeing like a physical communication, so physical wire like a USB wire, so USB also was one protocol. So we are using just port, like a physical port, but if you see inside our chip, they will work under the constraints of PCB protocol. So there are some restrictions, there are rules and regulation, like to make communications. So if you take an Ethernet to USB, so these are also protocols only. So it's not like a Ethernet wire, USB wire. So it is also protocol. It will works on our inside the chip. So they will communicate. They will perform some communication, means they will do so, they are some chips are following some protocol rules, like a USB protocol rules, Ethernet protocol rules. So protocols are everywhere in our electronic devices. So and then so it's time for if you guys are really interested, you can convert this masterclass into 1 month of internship on FEGA. So these are the benefits you will get at the 1 month of internship. So we are providing benefits of all 30 days recording session, all 30 days presentation, exclusive project codes. So will upcoming class we are doing some code only for FEJ protocol, FEJs implement of FEJ. So you can also downloadable. So and then VIP community group for doubt clearing and internship updates. And then IET internship so you will get the internship confirmation letter from IET. So and you will get also 90 days LMS course access and assignment task weekly live session for your doubt clearing. So and then we are providing some resume building ideas, mock test. So and then internship certificate and the participant certificates we are providing at the 1 month of internship. So this is the internship you will get at the discounted fee of just 999. So this is our regular fee 3,999. So by this the masterclass session period you can get a discounted fee of just 999. So by using this registration link you can avail our internship program. So this is a limited time period offer. It will close at 5/4/2025. So if you guys are really interested, you can avail our internship program. So and then we'll move to off-chip protocols. So till now we seen only on-chip protocols. So there are a lot of information, that there are a lot of topics in the on-chip protocols. So if you want to read the on-chip protocol, means firstly you have to read for AMBA, and then firstly you have to start from off-chip protocol. Then only we can move into on-chip protocol. So from the while writing the protocols, we are using only one logic. It's like a FSM logic only. So there is some, I said no, some rules and regulations, some step-by-step process. So if you seen in every code or every complex logic like AXI, APP or UART also, so we can declare some states. So we have to move from one state to another state. So we are using FSM very much in RTL design. So that's why FSM is very important. So coming to the off-chip protocol, so protocols for external communication. So it is, I already said, it is for external communication between the chip and peripherals like a sensor, memory, display devices. So we can use for the off-chip. We can use for the reasons we can use off-chip protocols. So and then the protocols are UART, I2C, SPI. So UART stands for Universal Asynchronous Receiver Transmitter. So it is a widely used protocol. So USB UART protocol is the USB to UART, UART to USB. So it is a serial communication protocol. So it will send the data transfer like serially. So it will start from bit by bit. So it will send one bit like a serial bit. So it like a serial communication. It will send the bit by bit. So if your chip are working, I will give the parallel output for UART input. But UART will works on serially. So it will send the first bit and then next bit and then third bit and then fourth bit. It will send by bit like a serially. So it's so that it will called serial communication protocol. So and also universal, why we called universal asynchronous receiver transmitter, means this particular UART protocol, it won't need a clock signals. It will work based on the start bit and the stop condition and the start condition and the stop condition. Based on the start and stop condition, we are make communication between the UART. So UART, coming to UART, so if you using the clock, we can easily synchronize the communication. So at every passage of clock, it will execute, it will send the data. So at every passage of clock or negation of clock, by using the clock we can make a we can make synchronization. But here there is no clock in UART, so that's why it's called asynchronous clock. So it will make communication synchronously by using the baud rate. So we have some certain baud rate like a 9600, 11.5, 12.00, so some baud rate. So baud rate is nothing but it will send the data like bits per second. So per second it will send that much of the data, so that much of bits. So it will, so main baud rate is it will send, it will define as the bits per second. So how many bits it will send per second means, we can say by using the baud rate we can say that how much of like 11,000 or 9,000 bits it will send. So but main thing is your receiver. So you have the two devices like a transmitter and receiver. So both transmitter and receiver must have to having the same baud rate. So it will have some, if you take a transmitter, it will work on based on 9600 baud rate of UART. So and also it is necessary to receiver also work based on the 96, so 9600 baud rate. So if both baud rates are same means we can make communication, we can make communication in UART. So if both baud rate are different means we can't make communication. We can't sure that our data will be successfully transmitted or received, or we can't assure that. So for that reason we can also use control flow. Some CTS RTS signal is there. So while writing the code in UART, I will say what is CTS RTS. So it's like a control flow signals. So by using that we can make we can make the communication proper. We can make the communication proper. So because of for example, your transmitter UART device works at the speed of, at the baud rate speed of 9600. So your receiver UART device works based around the 1 lakh 15,000 like 11.5200 baud rate. So this is works on 9600. This is works on 11 something like 1 lakh something. So there is the so there is a baud rate mismatch here. For that we can use also baud rate controller or converter in between the transmitter and receiver. So in that baud rate converter we have to set, so the transmitter will send the data at that much of baud rate, and then receiver you have to send the speed of that some particular baud rate. So by using the baud rate converter we can make, if you are using the two devices like a transmitter receiver, both are works based on different baud rate. By using the baud rate converter we can make communication in UART. But it is not a good way to make communication in UART. So you must have to use the same baud rate devices. Both transmitter and receiver devices must have the same baud rate, then only we can make communication. So you can also you can see some serial communication like a UART. So if you have ever experience with the putty serial communicator, so if you make a serial communication also, we have to perform the same baud rate. We have to give the same baud rate for good communication. So and then so this is the UART communication. So it will work based on the without clock, but it will based on the baud rate. So by based on the baud rate only it will communicate. So and then we'll move to the, so these are signals, transmitter and receiver. So it will baud rate will define rate of 9600 like this 11.5200 bit per second. So already we seen that. So this is the packet format of frame format of the UART. So it having firstly start bit, one start bit, and then and the end of the data, end of the packet, it having one stop bit. So in between, the data bits may be 5 to 9, so it may be 10 bit or 8 bits on bit. So we can send how many bits you want, we can send by it, but basically it must be less than 9, like 0 to 10. So in totally 10 bits only we can send. So we can send 0 to 9 means 10 bits as the data in the UART protocol. So and then parity bits, so it's for our it's like a checking purpose. So it's my data is correct data or not, like it's like parity. It parity is used for checking purpose. So it will works my data is correct or not. So that the transmitter will send the data to receiver. So how the receiver will ensure that it is the correct transmitted data or not? By using the parity bit, the receiver will check. So this is the correct data which is sent from the transmitter. So by using the parity bit, we can make sure that particular data byte or that particular packet is a correct packet. So I can proceed to on the next level. So this is a reason why we use the parity bit. So frame format of the UART is one start bit, we can use one or two stop bits, and then 10 data bits. We can use, mostly we are using 8 data bits, and we can also use for 10 data bits data frame. So and then one parity bit for the uh, checking purpose, so checking the packet. So this is a so why UART does not use clock, please? So it why maybe it's like a protocol reason, I don't know, but maybe I think in the UART protocol we didn't use clock. Why? Because of we will work based on the serial communication. So it is a serial communication. So it will send based on the baud rate. So it's like a bit by bit. So how many bit? So it's like a bit baud rate which based on the baud rate transfer. So we can make the serial communication. So if you use clock means, so there is a need for the clock input some. So I don't know clearly, but you are work based on the baud rate without clock. So that's why it's asynchronous. So there is no need for synchronization. So for that, so you can see here baud rate which you don't need. So you are which don't need for synchronization of start bit and the data bit, and then stop bits parity bit. So for that reason only we are using the UART protocol without clock. So in the upcoming class I will clear our doubt why UART don't use clock signal. So and then let's move to I2C frame format. So I2C is also one protocol. So it is like a off-chip protocol. If you are using the high-speed communications on the in the outside of the protocol, same thing, it having some start condition. So I2C stands for interconnected circuit. So it has start bit and then stop bit. So you can see here, and also you can also see here each and every clock pulse. Each and every clock pulse. So it has two lines, like a data line, clock line. So this is a clock line. So it will continuously. So I2C based on the clock. So it is the synchronous protocol. So it's not like a UART protocol as asynchronous. So each and every clock cycle data, you can see here, these are the slave address bits. So slave address. So each and every address it must be synchronous on clock. So you can see here based on the clock only it will get the address. So firstly we'll see the start condition. So what is the start condition for the I2C clock? So while clock is high. So if the clock is high on that time, if the data line sta is serial data line, so serial clock serial data line, so if it is while clock is high, so data will comes down, it means high to low, it will change high to low. We can see here, in here you can see data is high, so you can see this is a change like a low, high to low. But in the high period, the sta line is will change from 1 to 0. So we can say this condition, when clock is high, data line will change. When it is changed from 1 to high to low means we can say that it's a start condition. And then stop condition is same but a different opposite for start condition. When clock is high, but my data line of I to C is, it will change 0 to 1, so it will, so we can say that it is a stop condition. So this is a start and stop condition of the I2C protocol. So in UART we are using the one single bit, so and then here also one single bit for start and stop condition. But here we have some synchronized conditions, so synchronization between the clock and the data line and the clock line. You can also see data line and the clock line, we have to synchronize. So based on this transition, so if the clock is high, another time the data line will change 0 to 1 means it it will find that it is a stop condition. So this is a one data from I2C protocol. So that's why it's called synchronous. So the without the synchronization, we can say that it's a asynchronous. So and then it having some slave address, it may be 8 to 12 bit, and then read or write. So the R is refers to read or write from the master and slave. So and then acknowledgement. So acknowledgement is a one signal from, it's like a I'm saying to master. So if you imagine master and you having the master and slave, so you make communication between the master and slave by using the I2C protocol. Firstly, you have to send some start condition like while clock is high, your data line will change high to low. So this is start condition. So and then you have to send some slave address, and then you have to say some I want to read or write. So this is the thing. So and then you have to give acknowledgement. So if it is slave is acknowledgement, you can proceed to next address, next slave, or you can send data to slave. You can write or read based on the acknowledgement. If it is not acknowledgement means you have to wait for the acknowledgement at next try. So if it is if the slave is acknowledged means you can send the data to slave. So and then slave will send the acknowledgement to master. So I got some data which is sent from you. So I will say it's okay, my communication is perfect. So it's like a acknowledgement to saying to master. So and then stop it. So this is the communication of I2C protocol. So we'll see the communications, how to write the protocol. So mostly we are so basically why we need FSM means, so first if you taken this UART protocol, firstly you must have in the start condition. So this is a first stage, this is a second stage data transfer. So and then this is the third stage stop condition. So if you taken here also, firstly you have to based on this condition like a start and stop condition, we are saying if you are in the start condition, you have to move to slave address writing. But if you are writing, but if you are in the stop condition stage, you have to move to again start conditions to make next communication. So these are the state transitions will happen in while writing the RTL code. We are making the some states like a start state, stop state, slave address state, and the read or write state, and then data state. So we have to while writing the code, you have to write the logic for state changing only. We know that in the each and every state, we having some condition we can write easily in our code, but that state changing, it's a difficult thing while writing the I2C code. So it having lot of signal, it having some I2C signal, data read or write channel, read channel, acknowledgement, p enable, ready signal. So it's lot of internal signals it have in each and every protocol. So we have to synchronize all those signals in the I2C. But but in the UART you can't, you won't need to synchronize all the signals. It have only start data and then stop. So it didn't have any address bit also. Why? Because of it is a serial communication. We have only UART, like a transmitter and receiver only. So there is no need for address. It will continuously sending the data. So these protocols why we use it in our day to life in our chips, like mobile phones and computers, and also microcontroller and some electronic devices. So this is for today. We seen the on-chip and off-chip protocols. So mostly on-chip protocols are AXI, APP, AHP. So off-chip protocols are SPI, I2C, and USB, and also UART. We can say like that. So thank you guys. Thank you for listening. So we'll see tomorrow with the FPGA implementation, like a simple LED blinking on FPGA, Intel milestone Altera board. So and then day after tomorrow we'll see the motor control, like a DC motor, step by step motor. So it will do some operation like a step by step. So it will rotate the based on the steps. So we'll see the stepper motor, and then tomorrow we'll see the LED blinking, how to dump the code into FPGA, to how to assign the pin in the FPGA. So we'll see tomorrow. So thank you. So sorry, I think maybe tomorrow is Sunday. Tomorrow Sunday, so there is no class, but maybe in Monday, and Monday also some holiday. So I will update you in our groups, WhatsApp group, in our pantechelearning channel or LinkedIn. So maybe there is a class in Monday, and also coming week Mondays we will have the class. So tomorrow is no class. Sunday for Sunday, so Sunday is leave for our organization. So there is no class for Sunday. So thank you guys, thank you for listening. So thank you for your cooperation and your supports in our in my chat box. So we'll see upcoming classes. Thank you.